Good morning, students. This is Dr. M. Jannathul for the Assistant Professor of Chemistry. In today's class, we are going to see about introduction to polymers as well as classification of polymers. So polymers. Polymers are extremely important materials we have been using in our daily life. It has known since ancient times as cellulose, wood, as well as rubber. Biopolymers such as proteins, enzymes, DNA, etc. are the biomolecules which are also called as biopolymers. Recently, last 15 years, only there is a tremendous advances in synthetic polymers. What do you mean by word polymer? So it is a combination of two Greek words. Poly means many and mero means parts or units. A polymer is a large molecule of which is formed by repeated linking of the small molecules called monomers. More monomer molecules join in units to form a polymer. For example, ethylene molecule, if you are taking ethylene molecule n number of times, when it undergo polymerization, it forms polyethylene. So what do you mean by monomer? These are compounds that join together repeatedly to form a polymer in polymerization. What do you mean by polymerization? It is a process of joining together many small molecules repeatedly to form very large molecules. So when you take a monomer units and it is reacted with n number of times or undergo polymerization, it forms polymer. So this is how the polymerization takes place. Coming to the classification of polymers, polymers can be classified based on sources as well as composition, as well as structure, and finally intermolecular forces. So the first classification is classification of polymers based on source. So it can be classified as natural polymers. So those polymers which occur in nature, that is from plants or animals, are called natural polymers. Example, proteins, cellulose, etc. The next one will be synthetic polymers. So these polymers which are prepared in the laboratory are known as synthetic polymers. Example, polyethylene, polyvinyl chloride, etc. So next one will be semi-synthetic polymer. So these polymers are obtained by making some modification in the natural polymers by chemical means. Example, cellulose acetate, vulcanized rubber, etc. The second classification is based on structure. So the polymers can be classified based on structure as linear polymers. So these are the polymers in which the monomer units are joined together to form a long linear chains. These linear chains are closely packed in space, which results in high densities, tensile strength, as well as having high melting and boiling points. Example, high density polyethylene, nylon, and polyester. So this is the structure of polyethylene, which is an example for linear polymers. The other classification under based on structure is branched polymer. So in such polymers, the monomer units are linked together to form a long chains with some branched chains of different lengths. As a result of branching, these polymers are not closely packed in space. So they have low densities, low tensile strength, as well as low melting and boiling points. Example, low density polyethylene, starch, glycogen, etc. So this is the structure of low density polyethylene. Here you can see the branched type of polymers. The next one will be cross-linked or network polymers. The monomer units are linked together to form a three-dimensional or network-like structure. So will be classified as cross-linked or network polymers. These are expected to be quite hard, rigid, and brittle. Example, bakelite, melamine formaldehyde polymer, etc. So this is the structure of bakelite, which is an example for cross-linked polymers. The third classification is based on composition. So based on composition, it can be classified as homopolymers and copolymers. So what do you mean by homopolymers? The polymers which are obtained by the polymerization of a single type of monomer are called homopolymers. Example, if you take ethylene molecule or ethylene monomer, So when it undergo polymerization, and then it will be forming a polyethylene. So throughout the chain, the monomer unit will be the same. So this will be classified as homopolymers. The next one will be copolymers. The polymers which are obtained by the polymerization of two or more monomers are called copolymers. Example, styrene and butadiene. So it is a combination of two monomers, so which will be undergo a repeated linkage, so which will be forming a copolymer. So the best example is Buna S rubber. So the copolymers may be based on the arrangement. It can be classified as alternate copolymers, block copolymers, graft, and random copolymers. So in alternate polymers, the monomers, if you are taking a monomer A and B, which will be, it is comprised of alternate A and B units. So it is classified as alternate copolymers. Whereas in block copolymers, if you take two different monomers as A and B, it comprises of alternating blocks of A and B. If you look at this example, so a block of A and it is in one monomer, and a block of B is in another monomer. So this type we called as block copolymers. Whereas for graft copolymers, the main chain will be of one type of monomer. The another monomer will be formed as branches. So the A form the one type which will be in the linear form, whereas the B monomer will be branched. So this can be classified as graft copolymers. Whereas random copolymers, they will be following irregular order of arrangement of monomers. So here AB, it does not follow a proper or regular order. So the alternate polymer is and the random copolymer or the reverse form of the random copolymer is the reverse form of the alternate copolymer. The final classification is classification of polymer based on intermolecular forces. So it can be classified as elastomers, fibers, thermoplastics, and thermosetting polymers. So what do you mean by elastomers? These are rubber-like solid polymers which will be having a weakest intermolecular forces. So example, your natural rubber, Buna S and Buna N rubber, etc. Whereas fibers, it will be having a thread-like structure and can be woven into fabrics. So which will possess high tensile strength, it possesses strong intermolecular forces such as hydrogen bonding. So example will be nylon 6,6, terylene, etc. If you take thermoplastic, these are linear polymers and have a weak van der Waals forces. When we heat it, they melt and form a fluid, so which will be sets into hard mass on cooling. Example, polyethylene and polystyrene. The other classification will be thermosetting polymers. So these are normally semi-fluid substances with low molecular masses. When heated, they become hard and infusible due to the cross-linking between the polymer chains. Example, bakelite, melamine, and formaldehyde resin. Thank you. In today's class, we have seen the introduction to polymers as well as the classification of polymers. Thank you.